Hi, and welcome to AWS Innovate. My name is Steve Shirkey. I'm a solutions architect here at Amazon Web Services, specializing in machine learning. And we are so glad to have you joining us today for this series of sessions on ML services offered by AWS. This particular session, Demystifying Machine Learning on AWS, is intended as an introduction to what AWS has to offer customers in the area of machine learning and deep learning, and will serve as a jumping-off point to further topics covered today, including machine learning platforms such as Amazon SageMaker and computer vision services such as Amazon Rekognition. At Amazon, we've been making huge investments in machine learning since 1995. It's important to remember that many of the capabilities customers experience within Amazon.com are driven by machine learning. Our recommendation engine, which was introduced to customers more than 20 years ago, is driven by machine learning. Our Amazon Robotics division uses machine learning to determine optimal picking routes within our fulfillment centers. In fact, our entire supply chain forecasting and capacity planning are informed by machine learning algorithms. Beyond those use cases, ML enriches our customer experience in new and exciting areas of innovation, such as our drone delivery initiative, Prime Air, or our voice-based products such as the Amazon Echo, which leverages Amazon Alexa services, and the computer vision and sensor technology that power a revolutionary retail experience in our Amazon Go stores, where customers can walk out of a store without having to wait in a checkout line. All these efforts would not be possible without machine learning and deep learning. In fact, today, we have thousands of engineers at Amazon committed to machine learning and deep learning, and it's a big part of our heritage. As we just mentioned, the discussion of machine learning within Amazon is very wide and deep. But let's turn our attention specifically to how we are serving our customers here at Amazon Web Services. We are focused on bringing that knowledge and capability within machine learning to our customers. We can see here a list of several of our customers using machine learning on AWS today. Companies like Pinterest, offering a visual search engine powered by deep learning, or Expedia, helping to identify appealing photos of properties through a combination of crowdsourcing and machine learning, or Zendesk, which provides an online customer support platform used by more than 100,000 companies across the globe and relies on AWS GPU instances and the TensorFlow deep learning framework to create new applications for customers. Whether to increase innovation within your products and services or to reduce your costs via automation, more and more companies are starting to use machine learning in a meaningful way. And across all industries, more and more are choosing AWS as the place to develop and run those machine learning workloads. But we believe it is still day one, particularly regarding the use of machine learning. And many organizations are still looking at how they can leverage machine learning with their existing talent and resources. And that is why our mission is to put machine learning in the hands of every developer and data scientist, regardless of their experience, while still providing expert machine learning practitioners the breadth and depth of services that they need to achieve their business outcomes. So let's look at how customers are leveraging AWS for machine learning in different ways. From a macro level, we can think of our machine learning services as falling into three different layers. First, we have a foundation layer where we offer frameworks and interfaces for expert machine learning practitioners with complex requirements. Just above that, we have our platform services that make it easy for any developer to get started and go deep with machine learning while still gaining the benefits associated with managed solutions on AWS. And finally, we have our application services, a set of easy-to-use but powerful API-driven services that enable developers to plug in pre-built AI functionality into their applications without having to worry about the underlying machine learning complexity or to obtain the vast data sets that are required to build and train these services. Let's look at the frameworks and interfaces layer first. This foundational layer is suitable for expert machine learning practitioners that are already comfortable with building deep learning models, working with deep learning frameworks, building their own cluster of servers for both training and model inference, as well as managing and regularly patching the underlying operating systems. These are the builders that can get extremely deep into the details of creating complex machine learning solutions. And most, if not all, of these builders will already know that the vast majority of machine learning and deep learning workloads that are running on the cloud today are happening on AWS, leveraging our GPU instances. Let's look deeper at what is offered here. Our GPU instances, which are built around the use of advanced NVIDIA processors, provide builders with hardware that is optimized for machine learning and deep learning workloads. And that hardware continues to evolve. For example, our most recent GPU instance, the P3, is 14 times faster than the previous generation P2 instances. That translates into a huge boost in the speed and efficiency of deep learning and machine learning workloads. Quite simply, no one has anything close to the machine learning and deep learning performance that these GPU instances offer today. If we consider the question of machine learning frameworks, we find that customers still feel it is day one, and that they have not typically settled yet on a single framework for all of their machine learning needs. In fact, if you study the history of machine learning, the only constant has been change. So today, TensorFlow is the leading choice among many frameworks for deep learning workloads. And a recent study found that 88% of TensorFlow production workloads running in the cloud are actually running on AWS. And we still believe that choice dominates above all else, which is why we offer our deep learning AMI with a number of widely used open source frameworks that our customers love. Let's take a closer look at the diverse ways that our customers are choosing to implement their deep learning solutions at this foundational layer. GumGum scans social media images to extract meaningful data that provides insight for advertisers, and it requires analyzing more than 1.8 billion images daily. Their machine learning tool, Manatee, was built using the Apache MXNet deep learning framework and leveraging our P2 GPU instances, and helped them to reduce their model training time by 70%. Yelp publishes crowdsourced reviews of local businesses around the world, and the content provided by their users includes not only ratings and text-based comments, but also photos. And those user-posted photos greatly influence whether or not people decide to visit a business. So Yelp decided to develop an automated photo classification service that uses the popular Caffe deep learning framework and classifies and identifies the visual appeal of those photos, which helps to automatically select the appropriate cover photos for that business. Instacart is an online grocery delivery service that offers same-day groceries in several US cities. At its core, the service pairs customers with personal shoppers who search grocery stores to buy items that customers have ordered. Based on shopping patterns of millions of previous orders, Instacart used Keras and TensorFlow to develop deep learning algorithms which can predict and suggest the most efficient sequence of items to buy in any particular store. This helps personal shoppers to move through stores more quickly and efficiently and translates into 618 years of shopping time saved in aggregate. So you can see there is no one-size-fits-all framework, and therefore we will continue to support them all as we follow the ongoing evolution of machine learning and support our customers' need for choice. Unfortunately, while machine learning frameworks are plentiful, the same cannot be said for expert machine learning practitioners to develop these complex solutions. So we consider other approaches for customers that either do not have the resources or do not see the benefits that will offset the heavy lifting at this layer. So instead, we suggest looking at the platform services layer. If you think about the typical machine learning pipeline for building, training, and deploying a machine learning model, it is not easy, and there are plenty of blockers every step of the way. First, you need to collect and prepare your training data to discover which data sources and features are relevant to your business problem. Then you need to select which algorithm and framework you'll use. After deciding on all of that, then you need to train the model to make predictions, which requires a lot of compute and often involves tuning the model hyperparameters so it develops the best possible predictions, and this is often a repetitive and manual effort. Finally, after you've developed a fully trained model, you need to integrate the model with your application, as well as deploy the entire application on infrastructure that will scale. All of this takes a lot of specialized expertise, access to large amounts of compute and storage, and a lot of time to experiment and optimize every part of the process. In the end, it's not a surprise that the whole thing feels out of reach for most developers, not to mention data scientists who prefer an abstracted interface so that they can focus on the machine learning models themselves, not the underlying infrastructure. Fortunately, Amazon SageMaker offers an alternative to building your own machine learning pipeline and removes the complexity for both developers and data scientists. For maximum versatility, we designed Amazon SageMaker to support the machine learning pipeline as 3 separate modules: build, train, and deploy. that can be used together or independently to support any existing ML workflow you might already have in place, or to develop an entirely new workflow. First, the build. SageMaker makes it easy to build machine learning models and get them ready for training by providing everything you need to quickly connect to your training data, and to select and optimize the best algorithm and framework for your application. Amazon SageMaker includes hosted Jupyter notebooks that make it easy to explore and visualize your training data stored in Amazon S3. You can then connect directly to data in S3 or use AWS Glue to move data from Amazon RDS, Amazon DynamoDB, and Amazon Redshift into S3 for analysis in your notebook in a fast, secure, and scalable manner. To help you select your algorithm, SageMaker includes 13 of the most common machine learning algorithms pre-installed and optimized to deliver up to 10 times the performance you'd find in running these algorithms anywhere else. Amazon SageMaker also comes pre-configured with high-level APIs to run TensorFlow and Apache MXNet, two of the most popular open source frameworks, or you can bring your own framework as a custom container for use in SageMaker. Next, we have SageMaker Training. You can begin training your model with a single click via the Amazon SageMaker console, or a single call to the SageMaker SDK for Python, allowing for automation of your machine learning pipeline. The service manages all the underlying infrastructure and can easily scale to train models with petabyte-sized datasets. To make the training process even faster and easier, Amazon SageMaker offers hyperparameter optimization, currently in public preview, which can automatically tune your model to achieve the highest possible accuracy. Once your model is trained and tuned, SageMaker makes it easy to deploy your model into production so that you can start generating predictions on new data. As with training, you can execute deployment of your ML model using either one click or one command. Amazon SageMaker then deploys your model on an auto-scaling cluster of Amazon EC2 instances that are spread across multiple availability zones to deliver both high performance and high availability. It also includes built-in A/B testing capabilities to help you test your model and experiment with different versions to achieve the best result. So now we've outlined two layers that provide different approaches to the same goal: how to build, train, and deploy a machine learning model into production and solve a business problem. But what if you simply have a business problem where you require machine intelligence around common use cases, such as computer vision for performing facial recognition, or natural language processing to perform sentiment analysis, but don't want to go to the effort of creating custom machine learning models? Here we have a suggested approach in using the services contained in the application services layer. Within this layer, we have several services that allow developers and companies to immediately add solution-oriented machine intelligence to their applications via API calls rather than developing and training their own models. We will look briefly at what services can do that for you today. For computer vision, we have capabilities that provide support for both image and video analysis. Let's take a look first at what features are provided for analyzing your images. With our Amazon Rekognition image service, you can call the API with a given image and receive a number of different results based on your request. With object and scene detection, we can identify what objects can be found in an image, such as a bike or a person or an animal, to name just a few possibilities. Rekognition can also identify the image scene, such as whether the image appears to be a beach scene or a mountain scene. Additional capabilities such as facial recognition and comparison, facial analysis to identify demographic data, such as age and gender, as well as sentiment analysis, and newer features such as content moderation, celebrity identification, and identifying text and images. All these new features continue to expand the service capability since its initial launch more than a year ago. Here we can see an example of how a specific call is made to the Rekognition API and how it responds. In calling the API, the user provides an image, such as the one on the left, while calling the function desired, in this case, detect text. In response, the Rekognition image service will synchronously return a JSON-formatted response as shown in the example on the right. This information can then be used in whatever manner you wish. You can store that data in a database or start a sequence of events in some larger workflow. The choice is yours. This same fundamental approach is shared throughout all of the application services discussed shortly and allows a developer to easily incorporate machine intelligence into their applications, both existing and new. In addition to still images, you can leverage Amazon Rekognition Video to obtain similar computer vision capabilities for your video. Features such as object and scene detection, facial recognition, celebrity detection, sentiment analysis, and so on can be detected in the video you provide. But in addition, video offers additional context that's unavailable in images alone. For instance, with images, we may have two images. In the first, we see a man standing, and in another image, the same man is lying on the ground. But when we observe these images as frames in a sequence, as provided by the media of video, we can now identify motion context, which is identified by Rekognition Video. In addition, Rekognition Video can provide tracking to identify the path that a person has traveled throughout the video. All these capabilities help you to better capture information in your image and video-based content, information that would normally have been locked away in your stored media. So let's look at an example of Amazon Rekognition Video. Here we can detect from a video stream, we're at a party, that in the background a visitor is greeted with a hug, and we identify a balloon and a gift, while in the foreground, Rekognition also identifies that the child is opening a present. All these tags give meaning that would have been inaccessible without the insight of machine learning. Both Rekognition Image and Rekognition Video service can be used in either real-time or batch mode, meaning that you can upload and store your media within Amazon S3, our object storage service, and later run Rekognition against that media as a batch process. Or you can use the API in real time to capture additional information from news sources, such as user-uploaded content, and react to the data in real time. Let's look at a customer using Rekognition today. ArtFinder is an online art marketplace connecting more than 11,000 artists to art buyers in almost 100 countries around the world. In order to help match buyers to artists and their artworks, ArtFinder developed Emma, an AI-based art curator which recommends artworks based on deep learning models and using Amazon Rekognition to identify complex correlations between similar artworks. So far, they have used Emma to scan more than 500,000 pieces and counting, helping to provide users with the ability to search and discover art in ways that were never possible before. Moving on to the area of language services, we have Amazon Polly, which offers dynamic text-to-speech with lifelike voices. With Polly, you can generate audio using up to 52 different voices that speak 25 different languages, and you are provided further fine-grained control of the Polly voice, such as changing timbre or speed, or even adding the sound of a breath to your speech. Polly also provides speech marks to help synchronize your speech to subtitles, or even phonemes to synchronize mouth movement and animated characters. Finally, Polly offers custom pronunciation using speech synthesis markup language, or SSML, and your own custom lexicon for industry terminology or trademarks. Typical use cases for Polly include mobile application integration, telephony applications, gaming, and animation. Duolingo, a language learning service where users help translate the web and rate transactions, voices its language learning service using Amazon Polly. Duolingo found that Amazon Polly voices are not just high in quality, but are as good as natural human speech for teaching a language. Our latest service, Amazon Transcribe, works to convert speech to text and supports a wide variety of audio formats and audio quality, such as 8 kilohertz audio, which is typically used by call centers. It is directly integrated into Amazon S3, so you can just point to a file in S3 and it will transcribe it for you. The service provides timestamps and confidence levels for every word, so you can align text with audio, such as for syncing subtitles or searching the audio file for a particular word or phrase. Transcribe also produces output with estimated punctuation, making it even much easier for users to read the transcript. Potential use cases for Transcribe include call center transcription and further sentiment analysis, automated subtitling and broadcast video captioning, automatic transcription of meeting minutes, and tagging of digital assets for media companies, as well as many more use cases. Thinking about Transcribe and Polly leads us to consider how to use voice more effectively to engage users by capturing speech and converting it to text, performing some function on behalf of that user, and finally producing a reply. In other words, how to bring these services together and create a voice user interface. This is exactly what the Amazon Lex service does, powered by the same technology that is used by Amazon Alexa to provide automated speech recognition and natural language understanding. Lex performs these activities and provides an interface to your custom business logic, helping you to create your own chatbot. Lex also offers connectors to popular enterprise applications such as Salesforce and Microsoft Dynamics, providing all of this as a scalable managed platform. You can use Amazon Lex to build chatbots across a number of different contexts and platforms. Support is provided for both text and voice communications, as well as integration with popular platforms such as Facebook Messenger or Slack. Chatbots can serve several broad use cases, such as IVR systems for customer service, Q&A bots for more natural customer queries, enterprise automation of internal business processes and workflows, and many more potential use cases. Customers such as Freshdesk, which provide services for customer support for companies, are using Lex to create a more streamlined service for their end customers. Another natural language requirement is to translate text from one language to another, and with our new Amazon Translate service, you can perform real-time translation across 12 language pairs, including such languages as Chinese, Arabic, German, Spanish, French, Portuguese, and English, all powered by deep learning. Like many of our application services for ML, this can be used in real time as well as batch mode to translate documents or to produce localized content. Another service is Amazon Comprehend, which helps you comprehend unstructured text by extracting structured information from it. Amazon Comprehend can extract positive, negative, neutral, and mixed sentiment, and can extract entities like people, organizations, numbers, dates, as well as key phrases that provide important context, such as beautiful views in a hotel review. Looking at the sample text, we can see the following statement. Amazon.com Inc. is located in Seattle, Washington, and was founded July 5th, 1994 by Jeff Bezos. Our customers love buying everything from books to blenders at great prices. Using Comprehend, we are able to identify key entities such as Amazon.com, identified as an organization, and Seattle, Washington, identified as a location. Looking at key phrases, we have identified potential underlying topics such as customers or books, blenders, and great prices. We've detected as well that there is an overall positive sentiment informed by the second sentence. Had we just scanned the first sentence, the sentiment would have been identified as neutral. Finally, the language of the content has been successfully detected as English. One additional feature of Comprehend is the ability to analyze a large volume of documents and identify latent topics that emerge as a form of unsupervised learning. For instance, given a large corpus of documents and a specific number of latent topics, you can now group those documents into clusters where those documents appear to share the same underlying topic. This feature has allowed customers such as the Washington Post to automatically identify similar content and later recommend that content to users based on topic interest. So that summarizes our ML services that customers can take advantage of today. But if you're just beginning this journey into machine learning, how can you start? Particularly for enterprises, this can be a challenge as you want to accelerate innovation in your organization, but need some help in ramping up. And we can help with that as well. First, we offer Amazon ML Solutions Lab to those organizations wishing to accelerate their current data science efforts. ML Solutions Lab will partner with customers on proof of concept work and will help to provide the missing machine learning expertise that customers are requiring with the goal of transferring our knowledge to your team and accelerating machine learning results. These engagements are custom to your requirements, but typically involve your data scientist teams working closely with Amazon data scientists, often for several weeks, to achieve a machine learning deliverable. We also have several ML solutions available in our AWS marketplace, with partners such as SigOpt and H2O AI, and many others that can help you to accelerate your use of machine learning. You can find out more at this link shown here. AWS also has a wider partner ecosystem to help you focus on your success and take advantage of all the business benefits that AWS has to offer. To learn more about APN partners and find the right one that fits your needs, please visit the AWS APN booth at our showcase. To gain more confidence and hands-on experience with AWS, you can access our digital and classroom trainings built and delivered by AWS experts. Thank you once again for attending, and we really appreciate your feedback so that we can better understand the topics and services you'd like to know more about. So please do take the time to fill out our survey and let us know what you think.